Okay, so in this lesson we're going to be looking at how to solve some equations. Sounds basic enough, but we're going to be looking at some equations that might be kind of tricky. So let's start out by jumping right into a story problem here. So it says in the board game Monopoly, Boardwalk is the most expensive property. The one-time cost of the property is $1,400, while the rent earned from another player landing on it is $2,000. If n represents the number of players landing on Boardwalk, then f of n equals 2,000 times n minus 1,400. That represents the owner's total profit after n players have landed on the property. So this first part of the question just asks, what will be the owner's profit after 4 people land on the boardwalk? That's nothing new. That we know that we're going to put 4 into this function. So it'll be 2,000 times 4 minus 1,400. Which when you solve that, you end up getting $6,600. Okay, so that's not solving an equation, but the next step is, it asks, is it possible for the owner to make exactly $10,000? So when we see that word exactly, that means it's going to be equal to. So I'm going to set this equation. I'm going to set that up equal to 10,000. So to solve this, remember what I want to do is add 1,400 to both sides. Doing so leaves me with 11,400 on the right. And my last step then would be to divide both sides by 2,000. And when I do that, I get my answer for n is 5.7. Now here's the problem with story problems. You always need to make sure that you're answering the question. Because sometimes you do all the work, you get an answer, and even though you have the answer right and you haven't done anything wrong, we might not be finished yet. Because this particular question asks us, is it possible for the owner to make exactly $10,000 in profit? And since n represents the number of players, you're not going to have 5.7 players, so your answer would be no, it's not possible. Okay, the next one, we're going to skip part A because for that one it's just like part A for the previous problem where you just substitute one player in for n. For this one we're going to solve it or look at part B where it says how many players must land on Illinois Avenue. So your profit is at least $15,000. Now when you see that word at least, it means greater than or equal to because it could be exactly $15,000 or more than that. So when I set up this equation, I need to make sure I use the right symbol there. Greater than or equal to 15,000. So when I go to solve this one, I'm going to do just like the other one. I would add 750 to both sides. So in other words, our goal is to get the n by itself. And my last step then would be to divide both sides by 1,100. So I get n is greater than or equal to 14.3. Again, the goal is we need to make sure we read the question to make sure that we're answering it. And the question asks us, how many players must land on Illinois Avenue so your profit is at least 15,000? Well, think about it for a second, because if our answer is that the number of players have to be greater than or equal to 14.3, it means that I would have to have 15 players. Because 14 players would lead me to have less than $15,000. Anything more than 14.3 players would lead me to have at least that much. So my answer would have to be 15 players. And you should be familiar with the distributive property. So just remember that means that we multiply everything in parentheses by whatever's immediately outside of it. So let's look at an example where we do just that. So here we have Darius had $500 to spend at the baseball card convention. He decided to spend all his money buying rookie cards of his 2 favorite players. At the end of the season, Darius found that the first card increased in value by 21%, while the second card decreased in value by 7%. He spent D dollars on the first card, which means he spent 500 minus D dollars on the second. Let's stop there for a second. So if we know that he spent D dollars on the first card, and if he had $500 to spend and he spent all of it, To figure out how much he spent on the second card, we would take how much we had originally, minus what he spent on the first card, and that would leave us with how much he spent on that second card. So we're going to represent D as an amount that he spent on the first card, and 500 minus D on the amount that he spent on the second card. Okay, let's read on. So as a result, T of D equals 1.21 D plus 0.93 times 500 minus D. That equation gives a total value of the two cards. Okay, let's stop there now for a second. They give us this equation, but we're not always going to be given the equation, so it's really important when they give us an equation to be able to look and figure out how they came up with those numbers. Because I don't see 1.21 anywhere in the story problem, and I don't see 0.93 anywhere in the story problem. But we could have gotten that information without having been given this equation. Because remember, with percents, we never do anything with it as a percent. We always change it to a decimal. And as we look at this first percent, it says it increased in value by 21%. Well, what that means is that you started out with the original value of the card, which is 100%. At the end of the year, it's increased by 21%, which means we're now at 121%, which as a decimal is 1.21. The 0.93 says, or where we can get that from, is the second card decreased in value by 7%. Well, it still started out by the same original 100%, but by the end of the year, it decreased by 7%. If I take that away from 100, I'm left with 93%, or 0.93. Now, if I wanted to figure out the value of the card at the end of the year for the first one, I would take the 1.21 times what we originally paid for it. To figure out the value of the second card at the end of the year, I would take 0.93 times what we paid for it. And together, those two would give me the total value at the end of the season. So it says if Darius' cards are worth $550 at the end of the season, how much did he spend on each card? So to come up with my equation, I'm going to say 1.21D plus 0.93 times 500 minus D. So the total that it's going to be valued at the end of the year is $550. Now again, if we ever see, when you look at this, it looks pretty confusing. It looks like it might be a little tricky. But all you got to do is start by distributing to get rid of the parentheses, because that's going to make this a little easier to work with. And 0.93 times 500 gives me a value of 465. And 0.93 times D would give me 0.93D. Okay, now I want to clean this up a bit. On the left-hand side, I have 1.21D minus 0.93D. Now here's a note. Sometimes people think, oh, I have to subtract 1.21 from 0.93. They're on the same side of the equal sign, so we don't do that. Just ignore the 465 for now, and we're going to take and combine these like terms. So 1.21D take away 0.93D leaves me with 0.28D. We still have that 465 equaling 550. So next I would subtract my 465 from both sides. So I'm left with 0.28D equals 85. And lastly, I'm going to divide both sides by 0.28 to get the D by itself, which gives me 303.57. Now again, we want to make sure that we always answer the story problem. Let's look back to see what it asks us. It says, how much did he spend on each card? I only have one answer right now. So that answer gives me the value of how much he spent on the first card. To figure out how much he spent on the second card, I would take what he had originally, the 500, minus what he spent on the first card. And when I do that, it gives me how much he spent on the second card, which was $196.43. So now we've answered the question. So if you want to take some time to answer this next one, you can. Basically, you end up getting $25,000 for both answers, but I'll let you do the work, and you can check your answer. But again, you should get $25,000 when you do part B. But I want to focus now on this next part. because this is really important. Sometimes we're going to have equations that involve fractions. And I don't know about you, but I really don't like working with fractions. If I can avoid using fractions, I do everything I can. I try to pull out any tricks that'll help me get rid of those fractions. And that's what I'm going to show you in a second here. Here's the trick. If you want to get rid of fractions, multiply each side of the equation by a common multiple of the denominators. So let's look at this problem. Because in this problem, they don't even give us the equation. So right off the bat, we're stuck with a tricky scenario where we need to come up with our equation. It says in Game 5 of the 2006 NBA Finals between Miami and Dallas, Dirk Nowitzki scored 1/5 of Dallas's points, and Josh Howard scored 1/4 of Dallas's points. The rest of the Dallas Mavericks scored a total of 55 points. How many points did Dallas score? Whenever we're stuck with coming up with our own equation, we want to start by figuring out what our variable is going to be and what it's going to represent. Here's a little trick. It says Dirk Nowitzki scored 1/5 of Dallas's points. Josh Howard scored 1/4 of Dallas's points. So we're going to use P to represent Dallas's total points. So now when it says that Dirk Nowitzki scored 1/5 of Dallas's points, I can represent that as 1/5 P. We would add to that the number of points Josh Howard scored. Well, he scored 1/4 of Dallas's points. Well, if I add to that the number of points the rest of the team scored, the rest of the team scored 55 points. If I add up how much Dirk Nowitzki scored, plus how much Josh Howard scored, plus how much the rest of the team scored, that total is going to give me how many total points that Dallas scored. P. Okay, so now I have this equation. Again, I don't like the fractions. I want to get rid of them. So I want to multiply everything by the common multiple. What that means is we look at the denominators and figure out what's the number that both 5 and 4 divide into evenly. In this case, it's going to be 20. So I'm going to distribute. I'm going to multiply everything by 20, not just the fractions. I also have to multiply the 55 and the P at the very end there. I have to multiply both of those by 20 as well. How did I come up with 20? Some of you guys may be asking. An easy way to do it, if you're not sure of a number that both 5 and 4 go into, if you multiply the two denominators together, 5 times 4, that gives you 20. That trick will always give you a number that both divide into. It won't necessarily be the smallest. In this case it is, but it is a trick that will always work. Okay, so now let's do this. Let's multiply everything by 20. 20 times 1/5, or 1/5 of 20 gives me 4. 1/4 of 20 gives me 5. 20 times 55 gives me 1100. And 20 times P gives me 20P. So now I want to simplify what I can so I can add these two. That's 9P. Subtract 9P from both sides. When I do that, that would give me 11P on the right. Divide both sides by 11 to get the P by itself. So that gives me P equals 100. Now I want to make sure that I'm answering the question. So let's look back. It says, how many points did Dallas score? Sure enough, they scored 100 points. Okay, why don't you guys take a minute and do this next one, and then we'll check your work. Okay, so you should have paused the video, so in that way now you can check your answers. So let's check to see what you did. It's very set up very similar to what we did in the first one. That's 1/3 P plus 1/4 P plus 60 equals our total points. Multiply everything by 12. Doing so gives you 4P plus 3P. Don't forget to multiply 60 times 12. That's 720 equals 12P. And simplify the left. We're going to get 7P plus 720 equals 12P. Subtract 7P from both sides. I get 720 equals 5P. Divide both sides by 5 gives me P equals 144, and that's my answer.